Hello, this is Oval Lake. It's somewhere in Montana. Anyway, Oval Lake has some interesting characteristics. It has a boat dock to the south, a south boat dock at the bottom of your picture, and then it has a west boat dock, a south boat dock, and then it has a west boat dock. And if a person doesn't want to boat from one to the other, they can take the highway, this black line, they can take the highway 7 miles west and 9 miles north to get to the other boat dock. The man in charge, the sheriff of Oval Lake, is Bob. You can see he's in a little boat down at the south dock there. He's new. He's fairly new to Oval Lake, but it's his job to police the lake, and he wants to know how far is it by boat to go from the south dock. How far, there's Bob, how far is it to get from the south dock to the north dock? I'm sorry, to the west dock by boat. So along this dashed line, this is the lake, obviously. There's Bob. It would be good for him to know that, but he didn't bring a tape measure or anything to go that far. And so he'll have to use what's called Pythagorean Theorem to calculate the distance of that side of this triangle. The triangle made up of the highway 7. So if he got in his truck and drove, he'd drive along the highway 7 miles plus 9 miles, which is 16 miles to get to the other boat dock. We don't know the distance here. We're going to use Pythagorean Theorem, which is just a way of a fancy way of calculating that distance. So let's break away for a minute and look at the triangle and talk about Pythagoras. Now, I never took geometry, but I know this very basic idea that is often covered in algebra as well. And first of all, I want to explain a few things about this triangle. This triangle is called a right triangle. Whoops. A right triangle has one important characteristic. It has one right angle. Here, when you see that little box, that usually means that's a right angle. It means that this line and this line are perpendicular, which means they're at a 90-degree angle to each other. That makes it a right triangle. What we call Pythagorean Theorem applies only to a right triangle, but it is a very remarkable thing, and that's what I'm going to tell you about. So we look at a right triangle. It has what we refer to the two square sides as legs, or these sides, they're not necessarily square. These A and B are called legs, and truly for our purposes we could change them to A and B, it doesn't matter. And the letters represent the length of those two sides. Okay. C, the line C is called the hypotenuse. They always use the letter C to represent that diagonal line. Now, so A and B represent the length of those two sides that we talked about. Letter C is the diagonal. Okay. Let's back up. Okay. So 500 years ago, a fellow named, not 500 years ago, 2,500 years ago, they credit Pythagoras with this idea. And let me tell you, you see on this, on our right triangle, you might want to know let's say you know the length of any two of the lines. If I know the length of A and B, I can figure out the length of C. And if I know the length of C and B, I can figure out A. And it's not a simple matter of adding the letters, the lengths of the letters. If the length of A is 5 and the length of B maybe is 10, you can't just add them together to get the length of C. But the wonderful thing that Pythagoras figured out was that if you squared all three of these numbers, the square of all three of these numbers fit into this pattern, this formula, A plus B equals C. So when we say this, we mean the length of A squared plus the length of B squared will give us the length of C squared. And then you can convert a squared number back to an ordinary number. And so you can, if you know any two numbers, using A squared plus B squared equals C squared, with the right triangle, you can, if you have the amounts of two of the lines, if you have the length of any two of the lines, you can figure out the third one. And this particular thing is used, my understanding is, it's used over and over again in geometry because it's very, very super useful. And in itself, you can figure out the distance to a lot of things. So we've returned to Oval Lake, and Bob and his boat are way down below our field of view. And you can see that what I've done is I have the formula A squared plus B squared equals C squared. And what we want to know is the value of C, because C represents the hypotenuse, that diagonal line. And the way we do it is we plug the numbers in. So side A, the long side here I chose for side A, and the 7 miles for side B, 9 miles for side A. So I just plugged the numbers in. And the second step, of course, is to go ahead and change them from exponential numbers to ordinary numbers. 9 squared is the same as 9 times 9, which is 81. 7 squared is the same as 7 times 7, which gives us 49. So you can see that we can add those two together and get 130 is equal to C squared, or C squared is equal to 130. Now we've got an issue, is that doesn't really do us any good. We want to know the value of C. And so we remember from algebra that whatever you do on one side of the equation, you have to do on the other. So we can change C squared to C by doing the square root of C squared. The square root of C squared gives us C. But if we're going to square root the right side, we must square root also the left side, the 130. So the square root of 130, I used a calculator to come up with 11.4 miles. And so Bob calculates the distance from the south boat landing boat dock to the west boat dock is 11.4 miles, and he can do whatever calculations he needs in order to decide which way is the faster way across the lake, whether to get in his truck or whether to go in his boat. The boat may not go near as fast as a truck. Anyway,